transfer is defined as the movement of heat across the borders of the system due to the different temperature between the system and its surroundings. Heat can travel from one place to another in several ways. The different modes of heat transfer are conduction, convection, and radiation. In this video, we will explore what is conduction, how it works, and solve a practical problem step by step. Conduction is the process of heat transfer through direct contact between materials. Oh, it's you again. Examples of conduction are holding metal spoon in hot soup, touching a hot pot, and walking barefoot on sand, and many more. The rate of heat transfer via conduction can be described mathematically by the equation Q equals to K times A times T sub 1 minus T sub 2 divided by D, wherein Q is the heat transfer per unit time with the unit in watts. K is the thermal conductivity of the material with the unit in watts per meter Kelvin. And A is the cross-sectional area through which heat is being transferred with a unit in meters squared. T sub 1 and T sub 2 are the temperatures at 2 points with a unit in Kelvin or degrees Celsius. And D is the distance between the two temperature points with a unit in meters. Now, let's apply what we have learned with a practical problem. I have here a sample problem and we are going to solve this. A metal rod with a length of 0.10 meter and a circular cross-sectional area of 0.005 meters squared is placed horizontally with one end in a candle flame at a temperature of 90 degrees Celsius and the other end exposed to air at a temperature of 30 degrees Celsius. The thermal conductivity of metal rod is 300 watts per meter Kelvin. We are going to calculate the rate of heat transfer through the rod. To calculate the rate of heat transfer through the rod, first, we are going to find the given to our problem. After we found our given to our problem, we are going to convert our two temperatures. When we convert Celsius to Kelvin, we need to add 273.15 to the given numbers. After we convert our two temperatures, we are going to substitute our given to our formula. After we substitute our given to our formula, we are going to subtract our two temperatures, which are the 363.15 Kelvin to 303.15 Kelvin. After we subtract our two temperatures, we are going to multiply the 300 watts per meter Kelvin to 0.005 meters squared. After we multiply our two given values, we are going to cancel out the same unit. In this case, we have the same unit of meter. And then, we are going to cancel the 1m in 0.005 meters squared. And after that, we are going to multiply the 1.5 watts per meter Kelvin to 60 Kelvin. After we multiply our two given values, we are going to cancel out the same unit. In this case, we have the same unit of Kelvin. So we have 90 watts per meter. 90 watts per meter divided by 0.10 meter, we said a while ago that when we have the same unit, we are going to cancel it. In this case, we are going to cancel the meter. So we have 900 watts. So the rate of heat transfer through the rod is 900 watts. That example illustrates how conduction works in a practical scenario and emphasizes the importance of thermal conductivity and temperature difference in heat transfer. I hope you've learned something